Open the homepage of RC section calculator by going to www.episcalcs.com/rc. Click Data Input. The fields may be already filled in with the data from your previous calculations. If this is the case, then click Reset button. This will clear the data and let us start from scratch. Because the structure being designed is located in the UK, we want to use the British version of the Eurocode 2. Therefore, set building code to BS-EN. Now we'll set material properties to the given values. Set strength grade for concrete to C30-37. Set design situation to persistent and transient. Set grade for steel to B500B. Now we'll set parameters for calculations of concrete cover and bar spacing. Set validator type to automatic to code rules. The layout will be checked in accordance with the rules in the building code. Choosing other options turns off automatic validation and lets the user to control the layout manually. In accordance with Eurocode 2, the stirrup diameter must be at least 6 mm and at least 0.25 of the longitudinal reinforcement diameter. Therefore, let's try the value of 6 mm. The units used in the application are shown in the bar at the bottom of the page. We can see there that length is in millimeters, therefore enter in the field stirrup diameter 6. In the field C min, dur, enter 40. We don't know what level of quality assurance is going to be provided, so we'll assume the worst case scenario. Set quality assurance to no quality assurance system. In the field cover deviation, enter 5. This is intentionally incorrect value, so that we could get later familiar with data validation and error reporting mechanism. Aggregate size may influence required bar spacing. In order not to impose unnecessary restrictions on the aggregate, we use the value of 40 mm because the aggregate size will very rarely be larger than that. If later it turns out that we need dense reinforcement, then we'll limit this value. In the field aggregate size, enter 40. It's also possible to leave this field empty, then the relevant spacing check will not be performed. Now we'll define the section shape. Set shape type to rectangle. In the field width, enter 300, and in the field height, enter 400. Note that the section preview on the right was updated. Now we'll define the reinforcement. Let's try 4 20 mm diameter reinforcing bars. In the field default diameter, enter 20. In the field automatic reinforcement top number, enter 2, and in the field automatic reinforcement bottom number, also enter 2. Click Show Update Layout button to display the reinforcement in the section preview. Oops, the error message was displayed above the cover deviation field. The validation mechanism detected that the value which we specified is incorrect. Following the explanation in the error message, we'll change it to 10 mm. In the field cover deviation, enter 10. Click Show Update Layout button again. The reinforcing bars were distributed automatically in compliance with the building code provisions and are displayed in the section preview. The reinforcement ratio is displayed below the section and it is 1%. This looks like a good starting point. For now, we've finished with defining the section properties. Click Submit button. This will submit the data and bring you to the main menu. It's going to be convenient to open the results in a new tab in your browser. Right-click Uniaxial Bending and open a new tab. Go to this newly opened tab. On the right, there is an interaction diagram. The vertical axis is axial force and the horizontal axis is bending moment. When you put the mouse cursor over the interaction diagram, the values of forces in the picked point are displayed below in the Data Information panel. Sign convention is as follows. Positive X moment means the top of the section is in compression. Positive Y moment means the right of the section is in compression. Positive axial force means compression. We need to design the section, so let's focus on the Applied Forces panel. In the field Force enter 2000 and in the field Moment enter 140. Click Check button. The page is reloaded and the message with the check result is displayed. The applied forces exceed the section capacity. The point representing applied forces is displayed in the interaction diagram. We need to increase the reinforcement area. Go to the first tab, where the main menu is opened, and click Data Input. We'll add 4 additional bars. In the field Automatic Reinforcement top number, enter 4, and in the field Automatic Reinforcement bottom number, also enter 4. Click Show Update Layout button. The bars were distributed in 2 rows. Let's see if we can squeeze the bars in a single row by limiting the maximum aggregate size. In the field Aggregate Size enter 30 and click Show Update Layout button again. Now the bars are in a single row. Click Submit button. Open the second tab where the results are opened and reload the page by clicking Reload icon in your browser or pressing F5 key. Confirm reload if needed. The check for the updated section was performed and now the capacity is sufficient. In the interaction diagram we can see that the utilization ratio is high. Our design task is finished.